our next session is going to be focusing on harnessing AI and emerging technologies for biodiversity protection. As we have seen in the first talk, we just covered on the use of camera traps and some smart systems that are used in monitoring. So for the moment, we're going to be looking into the AI and other technology, drones, remote sensing, you can name them, on how they're also being integrated in biodiversity protection. And these are the key learning outcomes that we are also going to be focusing on. And the first one is to understand how AI is used to support modern conservation monitoring, identify practical tools such as drones, remote sensing, and automated detection system, compare conservation monitoring before digital tools and how technology has transformed it today, explore real-world examples of AI-driven wildlife protection, and lastly, recognize future opportunities and limitation of AI in biodiversity management. Within the room, we are honored to have Mr. Tom Gotes. He's a seasoned conservation professional with over 27 years of experience across South Africa's leading protected areas. He has begun his work as a ranger at the Heads Spruit Endangered Species Center and later advanced into senior management roles across multiple private reserves. And for the past 6 years, Mr. Tom has been a project manager with Wildlife Protection Solution, where he applied his extensive field and leadership experience to advance global endangered species protection. So without further ado, join me as we welcome Mr. Tom. Mr. Tom, the floor is yours.
Diane, much appreciated, and thank you everyone for inviting me to share my experience with you and show you what we are doing out in the field. All right, so Wildlife Protection Solutions started in 2013. It was a very different approach back then, where we got involved in actual rhino protection. And the funding of our project came from a couple in the United States that owned a software company. So they wanted to see how they can assist with protecting endangered species and trying to stop this carnage on rhino poaching, which really took a spike in 29 down in South Africa. We eventually started developing our own AI software, a platform called WPS Watch that you use for early detection. We realized that you either into rhino conservation or you into the tech side of it. So we got out of the rhino protection side of it, where we operationally started breeding rhinos non-intensively, and to see how we can use technology to further help conservation of endangered species in ecosystems. So we've got projects in 54 countries. Our main focus is Africa and Southeast Asia, but you can see on the map there, we're all over the globe. Got more than 3,500 cameras deployed. We process 65,000 plus photos per day. We've picked up on hundreds and hundreds of illegal intrusions during that time. So conservation tech has taken the world by storm, to be honest with you, and there are just so many different sensors that's coming into play, whether that's satellite imagery, drones, mobile devices, GPS tags on animals or animal collars, and camera traps. And that links into what Victoria was saying with all these different sensors. And how do you capture all of this data? Because now if you're lucky enough, you're sitting in a control room and you've got 20 screens in front of you and you don't know where to look anymore. So we've been part of a big process called the Gundi project. So behind the scenes, Wildlife Protection Solutions is also on the steering committee of AI2, also commonly known as Earth Ranger and SMART. So we sit on the steering committees of both those non-profit organizations. And we've come up with a platform which many of you might have heard of, that with the Gundi project, to amalgamate all of this in a real-time solution for protected areas. Now, we work with non-profit companies. We work with national parks, provincial parks, and private reserves to present everything to your field rangers and your conservationists out there on one screen, on one application, whether that be on your computer or on the telephone or on a smart device. And it just makes you more effective, and it links in quite nicely with the previous presentation as well, because it makes you more efficient. You can spend your funds better. It makes you more effective, whether that comes to ranger patrolling, deploying your people, where to deploy them, how to deploy them, when to respond, when not to respond. So it's become quite a big, like a balloon that everything is trapped inside of it, just to make it easier for people to monitor in real time what's going on within their protected area. But to focus a little bit on WPS Watch and what we are doing, it is a web platform. It's not an app for real-time monitoring using connected cameras. Primarily, we started off using it only for anti-poaching, to detect people, vehicles, people coming in with dogs to hunt, setting snares, etc., etc. AI has improved quite a lot. Now, we've been using AI for 10 years. When I got introduced to AI back in 2015, I was on the operational side of things, managing a protected area. And for me, it was a new world. And even though AI back then had a pretty decent success rate, coming from nothing to that, where we could start identifying human, vehicle, animal using connected cameras, to where it is today, where we can start doing species identification as well. So it's grown in leaps and bounds to assist us. It's helped us with human-wildlife conflict to detect animals coming into areas that cause conflict. There was a question earlier on from someone in the room. How do you use technology and to not marginalize your communities in conservation areas? Well, this is one way to help communities. They can help you monitor. You can give them early warning when lions are approaching their area, if they've got livestock, or whether they've got crops growing, etc., and just let them know to be on the lookout. And protected areas can become proactive and try and deter those sort of conflict by sending teams out. You can also do invasive species eradication. So this is not something we really do a lot of in Africa, but we do have projects elsewhere in the world where we monitor for pest species. But a lot of that will be feral cats and pigs, rodents. It's quite interesting. I haven't been directly involved in those, but it's always nice to see those sort of things coming through. Now, how does it work? So we can use camera traps, and like Johan Kruger said in his comic, camera traps have become affordable. You can use a normal SD camera trap, which you need to manually go and collect the data from, and then you can use AI to go through all of that data. Because if you go to a camera after a month or 2 months and you've got 50 of them out there, you've got tens of thousands of images that you need to go through to see what's been going past the cameras. TrapDagger is one of the software tools that you can use to do that for you. We focus more on connected cameras, whether that be CCTV type cameras, PTZ cameras, and then field trail cameras. That relies on GSM signal network. Now, we also know that a lot of this is not really available everywhere in protected areas. So it is one of the downsides of using the cheaper version of connected trail cameras, although it is extremely effective. We do have other devices that can run off Wi-Fi. This requires a little bit more work from our side in terms of putting down infrastructure. Thanks to Starlink, it's opened up another door for us to be able to put these sort of systems in place. where we create like a mesh network between the cameras that can talk to each other, they piggyback off each other and send the data back in real time. Protected areas are enormous. We can set up a mesh network. To give you an example, on a recent project in Namibia, we managed to put a camera into a valley 18 kilometers away from where the tower was, and it spoke directly back to the tower. So you can start monitoring areas that's difficult to get by on foot. It could be a long distance away. What we've also been able to do is, again, comes back to your effectiveness. You deploy your cameras where you have signal, and you can focus your foot patrols in areas where you do not have signal. So you become more effective in planning your patrols, because each of these cameras act as a patrol team. They don't sleep, they don't need an increase, so all really good. Still needs to be managed. You still got to have human in the loop. So the camera takes a picture, it goes through our algorithms back in Denver. Our server will pick up whether there's a vehicle in there, whether there's a human in there, whether there's an animal in there. That then determines where that picture needs to go. If there's nothing in there, it doesn't send it. And that's one of the advantages, is that you've got thousands of images coming in. You eventually get fatigue, where people miss things if they have to manually monitor every single image coming in. Just another monkey, just another antelope, whatever it might be, or there's branches in front of the camera. So the software and the AI technology that we use will filter all of those things out, make it, again, more effective. So the AI that we use is called computer vision models, or also object detection models. We don't do facial recognition or anything like that. And the reason for that is the type of cameras that we use. All our field cameras are black flash cameras. So black flash cameras, unfortunately, will make you lose some image quality. So your control room or the person in charge will then get the image or the alert on his phone via a WhatsApp message. They can then go on the radio and deploy the field rangers or reaction units to that area if they deem it necessary. You can see that's a typical sort of control room that we have in our office. We don't really monitor for people, but since we have staff working in our offices and they're there during the day, it is a big advantage to have all those eyes on the monitors and helping us look for any threats coming into a protected area as well. Specifically also nice because the Northern Hemisphere in the United States, where we are, is either 8 or 9 hours generally behind Africa. And so when we're sleeping, they normally awake. The guy gets it on his phone and he can react. So as an example, and this is really practical, this was based on one of our first successes many years ago, where we literally had communities living on the border of one of our protected areas. There was obviously endangered species around there, a couple of rhinos. Camera was placed on a very prominent trail. Guys came through, that's the actual image of people walking, carrying a bottle of water, backpack, and the guy following them had the gun. Just to clarify, we do not identify, or the AI cannot identify whether there's a firearm in the guy's hand. It's more a case of demonstration here, where we added the box around the firearm. Like you saw in my previous images, the whole person then gets boxed. So that image gets sent all the way across thousands of kilometers, goes through the algorithm, message gets sent back to the team. Reaction teams go out. They're obviously all armed, using night visions. We had a successful arrest that evening. That's the firearm that was recovered. Made the arrest, and no animals were lost during that time. Like I said earlier, we've been using it for 10 years in conservation. It's the new buzzword in the world. Everyone's talking about it. but it is improving, and it's almost improving on a daily basis, getting to the point where um, we, with the right type of cameras, will be able to do individual identification on animals as well. The success rate obviously varies. I started down to about 60% classification of human, animal, and vehicles, probably now close to 80-90%. I don't want to put it higher because I might put my foot in it, but it is really, really accurate in identifying those three specific objects in a photograph. Like I said, the black flash compromises the image quality, and that's the current reason why we can't do individual identification, but we can do key species identification. So when I say key species on the African continent, we're looking at most of the predators: elephant, rhinoceros, giraffe, zebra. We can do domestic dogs. It doesn't say domestic dog, just dog. And cattle as well. Again, cattle for your encroachment within protected areas. It works both ways. You want to try and keep the protected area clear of domestic animals or livestock, but you also want to protect the community's animals. So that's a typical image of people walking past the camera, and how the AI picked them up. You see quite well that guy's hidden behind the branches there carrying his firearm. Those are all fine. Those are rangers. No problem at all. So the guys getting the alert on their phone will be able to look at it and say, that's a friend, it's one of our staff. No need to react. Yeah, we've got a classic example of a poacher coming in with all his dogs to come and hunt. That will typically immediately be forwarded on to the reaction teams. Again, it might look like it's illuminated quite a lot. That's just the quality of the flashes that they use in the black flash cameras. Got a range of about 20 meters. So it is really hotspot monitoring. You need a lot of historical data, forward thinking of where you think the guys might be moving around. It's pointless putting a camera in a tree just because the tree is there and it looks nice to have a camera in there. It's going to work well. But if there's no movement, then if you don't have data, you're going to have to go and look at your animal movement. Where do they frequent? Where will they be most vulnerable? Surprisingly enough, have a look at these two photographs. The guys are walking on the road. It's nighttime. It's easy to walk on the road. It's also easier to track them on the road, obviously, as well. In South Africa, certain parks will have tarmac roads, and they've learned that you can't track them on those. So they do walk on those quite a lot. So we just had to improvise in where we're putting our cameras up. Here's a photograph of a moving vehicle. Still see it pick the guys up pretty well. 3 people identified, and the vehicle identified. Guys would have been able to say that's tourists on a safari, so no need for any concern. And then the animal identification, you'll see around each elephant there, at the top of the one at the back and at the bottom of the one in the front is a double line. We use 2 different AI models. The first one is to identify whether it's an animal, a human, or a vehicle. And then the second one is the species, the African species model that we're using. We didn't develop our own AI. We're using commercial licenses. We're working with these guys. They've got the teams and the funding to develop it. We pay our license fee, and we just use theirs at this stage. That might change. Again, species identification, not easy to see, but I can confirm that this was definitely identified as a leopard. Coming in out of the dark there is a rhino coming through. Lions. And yeah, so it really has been a game changer for your counter poaching units to become more reaction rather than walking and patrolling aimlessly at night. Apart from the dangers of doing that, if you have the cameras in the right places with the right teams, you can use the technology to your advantage, which brings us to using other sensors as well. We've worked with various companies on introducing and integrating fence sensors into our system. We deemed it unnecessary to have it as a real threat. So what we did in the background was work with the software engineers between the guys developing the fence sensors and the Earth Ranger team, and just to have it flowing in directly into the Earth Ranger platform. So they get again the one screen with the different sensors of where animals are moving, where people are coming through fences, acoustic monitoring, uh, animal collars, vehicle trackers, aerial trackers, personnel trackers. The list just keeps on growing as we're going on. But what we've embarked on now was the next buzzword around 2016, 2017 was drones. Drones is going to solve the problems of all poaching. The reality of that, unfortunately, um, it wasn't the case. Environmental conditions that impact drone use, vegetation, and you would immediately think just the thickness of the vegetation. Yes, that plays a big role as well. Heat retention. The heat retention coming out of certain types of trees, apart from rocks and your landscape, makes it extremely difficult with the thermal cameras to pick up human movement. We've done the test. We did it back in 2016, 17. The best of drones, $1 million, 3 months, not a single detection. Used as a great deterrent because of the noise factor and the visibility and light, etc. So it requires a lot of planning and strategy, how and when to use a drone. So you can use it proactively as a visual deterrent. You can use it to patrol your fences. And don't just think security. You can use it to patrol fences to have a look if there's been any animal breakouts. If you've had a lot of rain, to see if there's been flood damage on your fences, where to send your teams out. So instead of having a team driving around all over the park, you send a drone around. You can look for injured animals. You can look for animals that's been darted that actually managed to get away. And if you're not using a helicopter for the darting out of the vehicle, locate animals. There's talk of using drones for game counts, which you can do more on your mega herbivores and not really on your smaller things. Inspection of vulture activity deep in the bush. So these are all things that you can think about quite easily for using drones effectively. So for security, use it with a sensor. So a lot of guys will have what we call a drive and flies. They'll have a smaller drone in the APU vehicle. One of the sensors triggers, the vehicle will drive closer and send a drone out. Again, it will be a fence trigger or it could be a camera trigger. So if you put your criminal hat on, and you're out in the bush at night, noise travels, you drive a vehicle close, those guys will just go lying down in the bush. You'll drive past them. There's no ways you'll see them. Sending a drone out there is faster. It can go in a straight line. The guys will do a 360, hover. And we've had many successes from our partners with drones picking up human activity where it shouldn't be, or dog activity where it shouldn't be. So what we are currently getting involved with now, and this is a new project that we're going to start early in 2026, is called the Drone in a Dock, or the DJI Dock 3, where we're looking at a more automated system. So it's a proof of concept that we're going to be doing. There's a lot of red tape that we need to get around in order for us to successfully deploy these. We're looking at civil aviation, pilot licenses, etc., just general licensing, what you will be allowed to do and not. So the idea is to have the drone in the dock which still requires a pilot. In the first phase, it will always require the pilot. Second phase is going to be fully automated if everything gets signed off, where a sensor sends an alert through, whether that be a fence sensor, a camera trap, or an animal collar, which I'll get to shortly as well. And then the drone can fly directly there. Again, it's going to get there much quicker. You'll be able to assess and make your call from what do we need to do. Do we need to send a conservation team out there? Do we need to send a security team out there? What is the case? And how would you use it on an animal? In South Africa, we have a company called Rochelle. They've developed a collar specifically done on rhino. They are expanding that now to other species as well, like elephant and lion, where any erratic behavior from the animal will send a immediate ping to the end user, whoever that person might be, the ecologist or security. Now, erratic behavior would be lack of mobility if the animal hasn't moved, continuous running. If an animal goes down and they've got that erratic leg movement, sad to say, and you might not want to hear it. So when a rhino, for an example, gets shot, that's a typical behavior you're going to get. That sort of behavior from an animal will send a red alert out. And we keep on training the AI that the guys built into this collar to improve, whether it's going to be an amber alert or whether it's going to be a red alert. So I don't think this project is going to be a quick fix. We'll probably be do testing for the better part of 1 to 2 years before it's rolled out. But it will be the first protected area in South Africa and probably in the world trying to use a drone in a dock like this just for conservation management. That will be completely automated. And the downside at this stage is the costing of this sort of thing. We are still building the whole project and the budget for this, and we're already sitting at around $80,000. So it will not be a cheap project. So just to close off from my side, the human in the loop will never be able to be removed completely, not in the near future in any way. You always need to have that confirmation from an expert within your team to decide whether that is going to require intervention or a reaction or not. But it helps you to make better calls. You still need to manage it. You still need to maintain it. Tech can be your greatest friend, but it can be your biggest foe as well. We've all experienced it with computers or whatever it is that you might be using. It just doesn't want to work. Like myself, sharing here, and it just doesn't want to work. So if you don't keep your finger on the pulse and it starts getting away from you, it's very hard to actually catch up. But if you keep your finger on that, I can promise you it makes your life in conservation a whole lot easier. It still requires a lot of funding. So a lot of these projects of ours require funding from the outside, whether that be from non-profit companies like ourselves, other non-profits. We collaborate with other non-profits, or external funding through fundraising. It is still expensive. Prices are coming down. Like I mentioned earlier on, the common GSM connected trail camera cost is probably around $500 for a unit at the moment. So happy to take questions. Anyone in the room.
Thank you so much, Mr. Tom. And definitely, like you just concluded, every time, even though we can introduce technology, human intervention will be needed. But one thing I've learned from your presentation is that introduction of technology is a game changer for ant poaching, which has been a high challenge and problem to conservation results, in the world. And thank you so much for highlighting some of the greatest systems that have been put in place. We quite learned a lot from you. And yes, like you just mentioned, let's quickly get some questions from the audience. In the middle, I've seen Mr. Josh had raised his hand. I don't know if he's still with us, if he's in the room.
Tom, thank you so much. That was super interesting. I just had a question. I don't know how to phrase it, but are you, as someone that's working now closely with AI and stuff, are you nervous that poachers are also going to learn how to use this technology to poach and to counter what it is that you guys are doing? Or, like, yeah.
Yeah.
Shooting from the hip, not yet. I don't think poachers will be using AI specifically to assist them in the actual poaching. Down the line, it's like anything. I think there's good and bad coming out of everything. Depends on where your mind is. So they will put their mind to it. And if you ask me this question maybe 12 months from now, my answer might be different. Currently, I don't think so.
Hacking your systems to see where the animals are that you're monitoring and then go for those animals. But yeah, like you said, we don't know.
Yeah, we do vet whoever comes onto our system. Obviously, we rely a lot on the protected area itself that we're working with, that they would have vetted their staff and who they allow to get on there. We do have different levels of access onto our dashboard. So when you're at the bottom of the chain, you're a viewer, you can view photographs, but you can't view the map. You don't know where the cameras are.
Okay.
Our system and the integrity of the system is only as good as the management of your users and the profile users that you have or that you allow onto the system.
All right. Thank you so much.
Thank you, Marit, for a great question. Do we have any other more question within the room? Otherwise, if you allow, yes, Johan.
Maybe a question to both the experts. Are technologies being used to manage human-wildlife conflict effectively? I saw Eric's hand up earlier, or he asked a question in the chat. Eric is from the Masai Mara Wildlife Tourism College, and when we visited them earlier in this year, we saw how closely the community is living there with wildlife. And thinking about things like early warning systems, are communities embracing that? Because it's a two-way interaction.
Not to the extent that I would have thought they would. The engagement normally comes from NGOs that's working with the communities. I can top of my head, I think of like people like Elephants Alive. It works a lot in Mozambique. We work with Dr. Michelle Henley, and we have developed what we call, it's got various names. It's got BuzzBox, Human Wildlife Conflict Box. What we've done with that is it's got a motion sensor built into it, and you can put various sensors on that thing. You can have strobe lights, a speaker with noises. I didn't do this, that I facilitated a study on the reserves that I worked on by Canadians, where they were testing what sort of noise deters animals more than other noises. And without a doubt, human voices. You can shoot, you can have dogs barking, lions growling, doesn't matter. Human voices will deter animals. So we've got that box, and we've got a few boxes coming down to South Africa, because interesting that you asked them. I asked this exact same question to my engineers. I said, we've got these boxes we've been working on for so long. Why are we not embracing it? Why send me 10? Let's go put them out there somewhere. The word will go out. And it will definitely have an impact. And you can combine it with a camera if there's like signal, where you can actually have the camera looking at the box or with the box, whatever the case might be, and try and figure out what triggered it. Because you're going to get a lot of false positives as well. But if you have the box close to a kraal or where livestock is, or your crops, and there's elephant or there's a predator, then you need to engage with your community. It takes you to the next thing. Does the community have access to the tech so that you can warn them? That's the next thing that you would have to look at. Do they have access to smart devices? Because they would need that to receive the real-time alert. But since we thought of it when we start implementing wildlife conflict devices, we'll definitely go the whole Monty and just give them everything that they need, all the tools that they need to see how it works.
Thanks to both you, Tom and Victoria. It was two really fascinating presentations. Victoria, that story of the case study of the elephants testing the fence and, sharing the data with other conservation agencies, to me, it was really fascinating that, and also seeing the uptake in the technology when the data is shared. I think that's sort of science in action and conservation in action. So it shows that things can work when they are applied.
Yes.
Mm-hmm.
Thank you.
Mm-hmm.
Thank you so much to both of you.
Mm-hmm.
Pleasure.
Thank you. Mm-hmm. Thank you, Han. I want to see if I have any other person in the room before I take the opportunity to ask my question this time around.
I want to answer one question from earlier on, and if I missed it, my apologies, about the electrification of animals. So your general wildlife fence will run at extremely high voltage. To be effective, probably 6,000 volts to 9,000 volts. And if anyone has been zapped by one of those, it wakes you up. But it's got no amperage on it, extremely low amperage. So it really is a pulse.
Mm-hmm.
So you cannot be electrocuted like you would if you stick your finger into a wall plug and turn it on.
Thank you for answering.
Just to,
Our fence was actually 7,000, I think, so it was actually enough for elephants, but I think nobody got that. Like, people will be scared of that, and I didn't want to try, but yes, nobody got electrocuted.
Especially if it's holding like 18,000 joules, it really gives you a proper. If you've got a pacemaker, I think you might need to reset it after.
Mm-hmm.
Mm-hmm. Mm-hmm. So my question I have, since I don't have anyone in the screen who wants to ask a question, my question is about in terms of skills on how to operate this system or how to use these systems, either in monitoring or the use of drones or the use of remote sensing, AI systems. To both Victoria and Tom, since you're on the job market, some of the rangers that you have, do they have the right skills, or do you need even to first train them? I'm asking this question because we are with Mweka University. There are students who are soon going to come to look for jobs, to work in some of those parks. So is there a need for probably universities to remark that they need to emphasize, since we are introducing technology in conservation work, probably it needs to be emphasizing the curriculum of graduates? What is it like on the workspace? How is it? Do people have the right skills that game rangers or any other position above game rangers? Yes.
Tom, you want to go first?
Yeah, sure. So fortunately, I suppose if the younger generations coming through, most of them have got the basic skills of how to use a smart device. So in terms of monitoring and what to do with that, very little training is necessary. Behind the scenes, in terms of the maintenance, we do have to do quite a bit of training with the staff, and it's always ongoing as things improve and develop and people move around. it got to the point where we are actually looking at collaborating with, in South Africa anyway, with some of the ranger training schools to start looking at a basic wildlife protection WPS watch course, which they can add to their CV, to train them up in the use of all these different sensors. So it hasn't been a major stumble block, but there's definitely a need for further training, especially as we are diversifying quite quickly with where we're going and all the different tech.
Yeah, I think I would concur with Tom that it's good that technology has become very, very popular and anybody can use a smartphone, but it depends what you need to do. I think in my experience, the setting up devices, installation and maintenance require relatively highly specialized skills to collect good data, because you also want to ensure that what you set up is actually giving you good results. I think there is a general push forward to make systems more user-friendly, and I think Earth Ranger is a great example of that. But yeah, there are certain specific steps in the process that require definitely a higher level of skills. And it's important for academic institutions, education institutions to be aware of that and to give these tools to the new generation. And I think this also touches partially on like the question in relation to the local communities, how they integrate technologies in their lives to coexist with wildlife. Often it's even access to technologies and access to knowledge on how to use these technologies that is missing maybe.
Yes, thank you. Thank you so much. And we have another question from Rodolfo. Do governments in areas you are operating raise security concerns when these new technologies are deployed?
From our side, fortunately, not too many at the moment that I can think of. We are two countries where we've had initial resistance, but we've managed to mitigate and overcome the issues or the concerns that they had about the cameras and what it can do and who's got access to the data. It hasn't been a huge problem. And since I'm talking to people around Tanzania, that was probably one of the countries that we've had the most resistance from over the years, and only managed to really get into deploying cameras in Tanzania successfully about 2 years ago.
I think from my experience with drones, definitely also problems, like at least, again, Central Africa perspective, drones and Starlinks also not widely accepted and still illegal in some countries. So that limits the connectivity, so limits the solutions that you can apply with limited connectivity. And I think another major concern that it's not necessarily related to the technologies that we have discussed tonight, but data sovereignty as more things go on cloud. And there are, I think the big concern is about data sovereignty in different countries across the continent.
Thank you. I think Victoria just answered my question I had about if data has been sometimes misused, or how is the surveillance, the privacy of it? Could it be taken advantage of out of conservation benefit? But I think you just touched based on that. And I want to see if we have another question in the room. Otherwise, we are towards the end of our session. It's almost late. I want to appreciate everyone for giving your time and for staying with us within the room. Thank you so much to our great speakers, Mr. Tom and Dr. Victoria. Thank you so much for giving us your time, your experience, your expertise. We really appreciate.
Thank you for inviting me.
Yes, and this session has been recorded. We are going to be using it as a learning material people can refer to on our website, even on the YouTube channel of Share Screen Africa. It can be used for later use. So this was day 1 for our series with Mweka University, and tomorrow we have another session, which is about aligning tourism. Apologies as I correct. Well, yes, aligning tourism with sustainability and conservation. And generally, the talk will be about tourism sustainability. How can it be done responsibly? And I'm inviting all of you to please join us same time tomorrow. Thank you very much for joining us. And let me not close before I ask Mr. Tom and Victor if you have some concluding remarks for us before we end.
Thank you for the opportunity. It was a great experience and very interesting to always hear different perspectives, especially what Tom presented. For me, it's all new.
No, also I just concur. Thank you for the opportunity, and hopefully you could learn something, found something interesting there. Hopefully we meet each other somewhere down the line in the field.
Yes.
Okay, thank you very much again.
Yes, thank you so much. That was true. Thank you very much. Have a great night. Good night.
You too.
Yeah, you too. Thank you. Good night, everyone.
Good night. Good
Bye-bye.
night.